On this slide and the next slide, we're going to be dealing with parallelograms and their different properties, actually quadrilaterals and their different properties. So what I did here is I listed the different quadrilaterals that we've learned and the different properties about them. So a trapezoid is a quadrilateral that has at least one pair of parallel sides. A parallelogram is a quadrilateral with two sets of parallel sides. So we see here that a parallelogram is a special case of a trapezoid. Trapezoid has to have at least one. Parallelogram has two sets, and so it does have at least one. So a parallelogram, as defined here, would be a type of trapezoid. Under the definition, I listed the different properties that we learned. Opposite sides are congruent in a parallelogram. Opposite angles are congruent. Consecutive angles are supplementary, which means they add up to 180, and diagonals bisect each other. That means they meet at the midpoint. Another way of saying it is they split in each other into congruent parts. Next is the rectangle. The definition of rectangle is a parallelogram with four congruent, which end up being right angles. The reason I underlined parallelogram here is because a rectangle is a parallelogram, so it has all of the properties of a parallelogram. Sorry about that. So it has all of those properties. So in a rectangle, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. That's true in a rectangle because a rectangle is a parallelogram. A rectangle has its own special property, the fact that diagonals end up being congruent to each other. A rhombus, again I underlined parallelogram, but it's a parallelogram with four congruent sides. And again, since it's a parallelogram, it has all the properties of a parallelogram. It does not have the properties of a rectangle, just a parallelogram. And then on top of those properties, we see diagonals are perpendicular, so they intersect to form right angles or 90-degree angles. And diagonals bisect opposite angles. And the last thing is a square. A square is defined as a parallelogram with four congruent sides. Well, since it's four congruent sides, it makes it a rhombus, and four congruent angles, which makes it a rectangle. So a square could also be defined as a rectangular rhombus or a rhomboidal rectangle. But it's got four congruent sides and four congruent angles. So a square has properties of all the things above it. It's a parallelogram, so it has all those properties. It's a rectangle, it's got that property, and it's a rhombus, so it has those two extra properties. So using those different properties, we can answer these four questions and the next questions on the next slide. So up here, number 18, it says if OR is 13, then PQ is blank. So OR, if that's 13, what is PQ? Well, we want to find, that's this length over here. Well, since it tells us this is a parallelogram, we know opposite sides are congruent, so that's nice and simple. That also has to be 13. Number 19 says if angle O is 145. Now, I did not type that correctly. I should have put angle, let's put it down here. That should have been measure of angle ROP is 145. Because angle O could refer to this angle, or this whole thing. So we need to name it angle ROP. And so that's 145 degrees. And we're trying to find what's the measure of angle ORQ. ORQ, that's this angle down here. Well, we know that consecutive angles are supplementary, and those are consecutive angles there. And so they're supplementary, so they have to add up to 180. So to find that, we could just do 145, and we're going to subtract that from 180. That gives us 35 degrees. Number 20 says if OPQR is a rhombus. So it's not just a parallelogram now. They're saying, what if it's also a rhombus? Well, if it's a rhombus, it now has the properties of a rhombus and a parallelogram. And so the ones on top of the fact that it's a parallelogram are down here. Diagonals are perpendicular, And diagonals bisect opposite angles. So this one says if OPR is 16, OPR is 16, so that's this angle right here. If that's 16 degrees, what's RPQ? RPQ. What's this angle? Well, because of what we just read, that diagonals bisect opposite angles, so it's going to bisect this whole angle. It's also going to bisect this whole angle. And so if it bisects it, then this angle has to be 16 also. And then again, if it's a rhombus, what's the measure of angle OSP? OSP, that's asking for this angle right here. Well, that's where the diagonals cross each other. And what happens when diagonals intersect? They are perpendicular. Perpendicular means they're right angles or they're 90 degrees. So we're able to use those properties to answer those questions. Continuing to the next group of questions, these always, sometimes, or never. We're going to still use our properties of parallelograms and quadrilaterals, remembering that a square has all the properties of a rhombus, rectangle, and parallelogram and trapezoid. A rhombus will have its two properties and the parallelogram properties, always, because it is a parallelogram. Rectangle has its one property. On top of that, it will have the properties of the parallelogram, and then the parallelogram has its properties, and then there's the trapezoid. So, number 22, the diagonals of a parallelogram bisect each other. Well, that is a for sure thing. It says it right under there as a property of parallelograms, so that's an always. That will always be true. Next, the diagonals of a parallelogram bisect opposite angles. So it's asking about a parallelogram. Do we see that under parallelogram that diagonals bisect opposite angles? We don't see it there in our property. So look in here, we do not see that property. So we know that it's not always. But can it be true? Well, yeah, it can be true because we see it down here in this group of two. We see that diagonals bisect opposite angles. So, and a rhombus is a type of parallelogram, so we know that that's true. Sometimes it's true if it's a rhombus, but it's not always true. So we would put sometimes here. So for example, I just want to show you, if you had a parallelogram that looked like this, we can see that a diagonal drawn here does not bisect the angle. This angle is much smaller than this angle. But then if you had a rhombus and you draw one of those diagonals, yeah, it does look like those are bisected. So we can see that also. Opposite sides of a rectangle are congruent. This is number 24. Opposite sides of a rectangle are congruent. Well, let's look at it under a rectangle. Do we see that there, that opposite sides are congruent? We don't see it under rectangle, but again, we remember that a rectangle is a parallelogram, and under a parallelogram, we see the opposite sides are congruent. So that's an always. I'm just going to put an A this time for always. Diagonals of a square are congruent. Well, we don't have any properties written under square, but we know that a square is a parallelogram. It's got 4 congruent sides, which makes it a rhombus, and it has 4 congruent angles, which makes it a rectangle. So a square has a lot of different properties. So diagonals of a square are congruent. Well, do we see that anywhere, that diagonals are congruent? Well, in a rectangle, we see diagonals are congruent, and since a square is a type of rectangle, it's got to be true. That's an always. And the last one says diagonals of a parallelogram are perpendicular. Well, we don't see under parallelogram, we don't see that it says diagonals are perpendicular. So we know it's not always true, but can it be true? And we do see down here again in a rhombus that diagonals are perpendicular. And so it doesn't have to happen, but it can happen, so it's sometimes. We can actually look at our figures over here again. If I drew in this other diagonal, these definitely don't look perpendicular. But if I drew this diagonal in, it's like, yeah, they look perpendicular. So it's a sometimes. So being able to determine if properties are always, sometimes, or never true.